So next up we have Pavel Dorovskoy from CarbonMapper. Did I say that?
Hello.
CarbonMapper.
CarbonMapper.
Yeah, CarbonMapper.
Yeah.
Cool. So over to you.
Trying to share my screen. Okay. Well,
Yeah.
I apologize for the 4 minutes taking up 80% of my presentation.
No worries at all.
Okay. So basically, CarbonMapper is a coalition of multiple organizations such as Planet, JPL, Arizona State University, and some other organizations. And what we're trying to do is we're trying to map all of the methane and carbon emissions on the planet. So it's a pretty lofty goal. You know, we plan to have 30 satellites in orbit. The satellites are going to be controlled by Planet, and CarbonMapper is in charge of basically ingesting, processing, and doing the work of detecting plumes so that the emissions can be mitigated. So it turns out that the majority of the emissions come from a small percentage of actual plumes. So this is some quick visualizations. And you know, if basically we detect, we have good coverage, we identify the biggest plumes, we can very easily mitigate the majority of the emissions that happen. And as and the methane is one of the biggest contributors to much bigger contributor than CO2 to the global warming effect. So brushing ahead a little bit here. So we have a lot of historical data. So this is not a brand new mission. You know, we have sensors that were collecting hyperspectral data from airborne missions going back to 2015. So CarbonMapper is new, and I am basically working on building a data platform to incorporate all the previous research work and accommodate future mission of the satellite launch, basically. So the historical data from airborne is about 100 terabytes from 2015 to 2021. And there's a lot of stages of processing to the data, you know, from the hyperspectral data where we have 432 bands, it gets reduced down to just a few bands of that indicate the actual sort of concentration of CO2 and methane. So, you know, we're using AWS cloud right now, S3 for storing the data. And we're going to use various tools to basically dynamically process this at a scale as the scale, basically the satellite constellation scales up. So, but right now we're basically practicing on the airborne data. So, but even with that data, it's quite large. You know, we might want to reprocess some of this historical data as we test new code, for example. And there's all sorts of other things happening because the airborne data keeps coming in. There's actually going to be more flights ongoing, basically. So perpetually, we're going to be adding 30 terabytes of airborne data a year. And the satellite data, I can't really say how much it's going to be, but it's going to be a magnitude larger volume. So it's a very large data set. So the way that the STAC is really helping us is actually categorizing and exposing the access to the data via the STAC API as opposed to file system, which is what a lot of researchers are used to. So if you think about how traditionally this research has happened, people have worked with the file systems in the cluster at JPL or NASA, and those things have worked at a certain scale, but as we are going to scale up a lot more, we really have to think about things in more encapsulated fashion. And STAC API is basically a fantastic standard to start to implement as part of the existing operations and as part of the framework going forward. So basically, we have both manual data generated by users, and we have automatic data ingestion going on at the same time. And we're going to be triggering workflows based on these inputs. And we want to reuse as many STAC tools as possible. So we want all of the AWS batch and step functions calling STAC API search and accessing analysis-ready data as opposed to rely on faucets and things like that, because that approach, old-fashioned, would just not even work. So this is the basic architecture that I can present, and that we have the spatial temporal asset catalog as basically the sort of the fundamental piece of the entire infrastructure. And around that, it powers also all things around it, such as the processing pipeline, the data services for data consumers who are going to be consuming the products that we generate, and web visualization as well. So some of our users are going to be CARB California Area Source Board, but they're also hopefully we're going to have other consumers and regulators that is all kind of in planning stages right now, but that's the goal. The goal is to basically expose the methane emissions data so that multiple organizations around the world can use it to regulate and prevent emissions going forward in the future. So it's going to be a highly impactful mission. So that's pretty much it. Sorry about taking up all the time.
Great.
Yeah.
Thank you very much, Pavel. It sounds like a really interesting project, and I think that merging of the satellite data and aerial imagery and drone data is a really interesting space. We got any questions coming in for Pavel? So Ryan Abernathy, I think this is more of a comment, says methane is a bigger contributor to greenhouse warming per unit mass, but the total CO2 radiative forcing is much larger because there is much more CO2 emissions. Not sure if you want to respond to that one, Pavel.
Oh, sure. No, I think that's a very, very valid point. And we are going to be mapping CO2 plumes as well. So it's a CarbonMapper, that's a carbon name. So we're going to be looking at both. So far, methane has been kind of the easiest target because of the airborne emissions, but we're going to be mapping both. And we're concentrating on plumes and things that we can prevent. The issue with, I think, with the sort of more background and dispersed emissions is that it's harder to map with hyperspectral. So there's different approaches to reducing it, and I think from what I understand, what the scientists are saying, methane is kind of the lowest methane emissions from landfills and oil producers. Pipelines are kind of the lowest hanging fruits. Some of them emit so much methane that they can fix with just a few phone calls. That it is pretty egregious, basically. And there are some articles about it that I can share. Yep.
Cool, great. All right, well, thank you very much for your presentation, Pavel.
Sure.
And the next